Okay, so here we have the front panel board all put together with all the transistors, LEDs and stuff, and you can plug the paddles into it just like you do with the tube boards. And here of course is the Raspberry Pi plugged in with the GPIO connector and the USB cables. Well, you can't quite see them, but here's the USB cables going to the paddles, so that's all rigged up. Now this all it needs is 5 volts here. Of course, there's no high voltage on this board, required for power supply. So I just have a regular Raspberry Pi power supply here. And these supposedly are good for, like 3 amps or so. And the Raspberry Pi itself takes like a half amp to a 3/4 of an amp. So it should be enough to run the Raspberry Pi and the LEDs and all that stuff. So I'll plug that in, give it a few seconds to boot here. But anyway, there's a test program that takes signals out of the GPIO connector and puts them into the paddles, so they should be able to be read by the USB, and vice versa. There are pins that go this way, so you put data in the paddles and it should make it to the GPIO connector. And it also should light up the LEDs, of course. So, and it just does, again, just sends random numbers both ways and make sure the random numbers can get through. So I'll bet this Pi is booted. I have the keyboard over here. So hopefully, I have the keyboard over here, so hopefully I can get this uh, Raspberry Pi going. Yeah, there we go. I'll get the test program running here. So there it is. Okay. So the test program is the same test program as with the sequencer board. You just tell it, oh, I have the Raspberry Pi board. And so this thing is working. It would stop if there was an error. Here it would stop and say, oh, pin blah 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 is grounded or whatever, stuck on 0 or stuck low or stuck high. Um, and it just randomly blinks the LEDs, except somewhere in here it's supposed to theoretically walk one around. I don't know if it's easy to see or not, but oh yeah, there it goes. And then like that, and then like that, so I can see the 1 and 0. So it's walking this around. The idea was to test, if the wiring isn't right, but the only way the wiring, two of them could be crossed is if the printed circuit board was bad, and that's not, extremely unlikely that. But this is pretty simple test, and it's just cranking away, sending random numbers out this way, reading them back, and blinking the lights with random numbers, except for this one here that it walks along, and it's hard to see it, isn't it? Yeah, there it goes. 1 followed by a 0, and it should uh, turn the other way at some point. That's more to see, does the program work than the LEDs, So now it should reverse direction here. Yeah, now it's going back the other way. So, all right, so we can see that all the LEDs are lighting up. So that means that, they'll able to see the accumulator, memory address, program counter signals coming in from the bus here. Normally, this goes to the backplane. And so the signals come in on the bus here and just light up these lights. And there's also, instruction register, and then the various state flip-flops light up these lights here. So really, all the flip-flops and the whole computer come out here, except there's a couple of control flip-flops that are not here, that are just used to arm writing to, let's see, I think it's the accumulator and the memory address register. There's a flip-flop that just sets for 1 cycle to gate the clocking for those flip-flops. But otherwise, the main flip-flops are all shown here on these LEDs. Oh yeah, and also there's an instruction register bit 8 that's not shown here. And the only thing that does is that saves the indirect bit, so it can do a data frame, so it can tell the Raspberry Pi use the data frame when you have the memory extension stuff running. It just says, oh, this is an indirect reference and memory reference instruction, so use the data frame instead of the instruction frame. So that's a bit that's not lit up here. Um, but otherwise, you have the main registers here and the states here. So that's a pretty short one there for the LED board, because it pretty much just worked right off the bat there. So that's good. Again, it's Raspberry Pi. The autoboardtest program sends random numbers out here. Make sure it can read them in the USB, and that sends random numbers in the USB, and make sure they get to the right GPIO pins here. So I guess that's it. A short video for that board. Next will be plugging these into a backplane. This Raspberry Pi LED front panel board, along with that sequencer board and the paddles. So you get all three of those plugged together on a little backplane board, and then you should be able to send signals out to GPIO out to GPIO, and it goes to the sequencer, and the sequencer should be able to step, and then the Raspberry Pi should be able to read results back from using the GPIO connector here, as well as double checking them with the paddles. So that's it for this one.